So another useful category of forces are centripetal forces, and these are basically just forces moving in circles. We've had some experience with these already, so recall from previous chapters, we know about kinematics, we know about things moving in circles. They have some acceleration, some centripetal acceleration that's equal to v squared divided by r. And we've seen this, and we discussed this when we have something moving in a circle, right? We have velocities. So maybe over here on the right hand side I have a velocity going up. I could have the exact same magnitude of the velocity at the top of the circle, but to be moving in an actual circular path, I have to change the direction. And that change in direction is what is responsible for us having a centripetal acceleration. Now the direction of that centripetal acceleration is always going to be perpendicular to the velocity, so it's always going to point towards the center of your circle. So your centripetal acceleration always goes towards the center of the circle. And thanks to Newton's laws, we now know that the sum of forces acting on something moving in a circle is equal to the mass times the acceleration of that object in a circle. So we now have this wonderful equation for the force of something moving in a circle. And there are all sorts of reasons that you could have something moving in a circle. All sorts of forces can be responsible for this. So this is not some kind of special force that exists. It's a regular old everyday force that's responsible for being centripetal in nature. So if I'm swinging around something on a string, in a rope, in a circular shape, in a circular path, then tension is what's responsible for that circular motion. If I'm on a roller coaster and I go through a loop-de-loop and I feel a force pulling me towards the center of that loop, that force is gravity. If I'm driving in my car and I go around a curve, my car doesn't slide off of that curve, it doesn't slide off the road, because friction provides a force that's centripetal that keeps me on the road. So let's see this in the form of an example. So let's say I'm driving on a flat curve. So this curve is not banked, it's not at an angle. I need to calculate what the centripetal force is exerted on a 900 kilogram car that goes around a 500 meter that goes around a curve of radius 500 meters at 25 meters per second. And then if I assume that I have an unbanked curve, what's the minimum static coefficient of friction that will keep the car from slipping off of this road? So let's follow our procedures for solving problems. Let's write down everything we know. We know the mass is equal to 900.0 kilograms. We know that the radius is going to be 500 meters. And we know the velocity that I'm going at is 25.00 meters per second. In part A, I'm asked to find what is the force. What is the centripetal force that this car feels going around this curve? So I can write out an equation for centripetal force. Centripetal force is m times v squared over r. That seems relevant to me. And if I can look at these variables, these things I know the mass, I know the velocity, and I know the radius. So I can plug all these numbers in, and I can solve this problem right away. 900 kilograms times velocity squared is 25 meters per second, quantity squared, all divided by the radius of 500 meters. And this gives me a centripetal force that's equal to 1,125 newtons. So that was pretty straightforward. Now part B, we're asked to find what is the coefficient of static friction. So we need to find mu s. Well, to do this, I need to turn to this picture again. I need to look at this picture more closely and identify what's going on. I need to draw the picture. So let's see, we have some weight for this car, right? Gravity is pulling it down, so that's the weight. That's equal to mg. We have some normal force because the car is sitting on the road. That's acting up. We have a centripetal force. The centripetal force is acting towards the center of this circle. And what you need now is to identify what's responsible for this centripetal force. What is keeping my car having a force pointing towards the center of the circle instead of it kind of slipping and sliding out of this arc and ended up flying into a tree or something? So the force that's responsible for this, for preventing this blue arrow from actually having an impact on the car, that's preventing my car from sliding off the road, is the force of friction. So the centripetal force is the force of friction. We'll say that one more time. The centripetal force is supplied by friction in this case. So now I can write out that I know that my centripetal force, F sub c, is equal to the force due to static friction. So FC has to be equal to mu due to static friction times the normal force. And if I want to find what the coefficient of static friction is, I have to solve that. Mu s is Fc, the centripetal force, divided by the normal force. So now I need to figure out what's the normal force here. And I can take this, I can figure this out based on my picture. I have these sum of forces that I've drawn. The sum of forces give me sum of forces in the y direction. I have a normal force acting up. I have the force of gravity, W, acting down, and that's got to be equal to 0 because this car isn't bouncing up and down. It's not leaving the road. It's not going airborne. It's staying in contact with the road. So the normal force has to be equal to the weight. So the normal is equal to mass times gravity, and I can plug that in to my equation that I've just derived. So my coefficient due to static friction has to be equal to the centripetal force, which we just calculated was 1,125 newtons, all divided by mass times gravity. And I can plug those numbers in, 1125 newtons, divided by the mass, which we were told in the problem was 900 kilograms, times the acceleration due to gravity of 9.8 meters per second squared. And I plug all of this in, and I can find what my coefficient due to static friction is. And I should get 0.13. And this is a great example of how friction supplies a centripetal force. So this is a combination of multiple different kinds of forces acting in different ways.